I think here S is not important in this question, but let's go with the description first and then we'll be solving this. Count collisions on a road. There are n cars on an infinitely long road. It is not, let me say this, it is not like a space like horizontally or vertically, but let me tell you that's like a desert. Let's be clear in that. The cars are numbered from 0 to n minus 1, from left to right, and each car is present at a unique point. Okay, you are given 0 indexed string directions of length n. Directions I can be either L, R, or S. Okay, denoting whether ith car is moving towards left, right, or staying at its correct current position respectively. Each moving car has the same speed. So S here means staying at its current position. It's not moving. Okay. The number of collisions can be calculated as follows. When two cars moving in opposite directions collide with each other, the number of collisions increases by 2. Okay. When a moving car collides with a stationary car, like staying at its current position is nothing but it is a stationary car, right? The number of collisions increases by 1. Okay. So if two moving cars collide, then increases by 2. If one car collides with a stationary car, it increases by 1. After a collision, the car involved no longer move and will stay at the point where they collided. Other than that, cars cannot change their state or direction of motion. Return the total number of collisions that will happen on the road. Let us take this example R L R S double L. So R L R S double L. Let me tell you. Let's take a car like this. You know, it is moving in the right direction. Okay, this is moving in the right direction. Let's take the same example. Now let's take another car which is moving in the left direction. It is absolute that these two cars will be colliding. Okay, let's now take another car which is moving in the right direction, and there is another car which is, at the stationary point. Now there are two cars moving in the left direction. Let me tell you, there are two cars moving in the left direction. There are two cars, wait, there are two cars moving in the left direction. Okay, let me tell you, if all of these will start, I don't know how to do the animation, right? So these two will collide for sure. These two will collide because this will come like this and this will come like this, and these two will collide. For now, let's say the answer for now, before it was 0, but these two are colliding, so it is 2. Now it is moving in the right direction and it will collide with the stationary car. So what will be our answer incremented by 3? Let me tell you clearly, this will not move, this will not move, and here I have incremented it by 1, so this will also not move. Now this is moving in the left direction, so it will meet the stationary car. So this will also increment our answer by 1. Now let's take this car. This is also moving in the left direction, right? So this will collide with this stationary car. Why? Because this is stationary, because this is moving in the left direction and it is colliding with the stationary car and it has made it stationary. Let me clearly tell you that when a moving car collides with a stationary car, the number of collisions increases by 1. Now, after a collision, the cars involved can no longer move and will stay at the point where they collided. Other than that, the cars cannot change their state or direction of motion. Okay. Now, this is also moving in the left direction and collided with this car and it will increment by 1. So the answer is 5. We will be returning 5. Let's take another example, right? LLRR. That's the best example to explain you what is our approach. LLRR. So this is nothing but, these cars are nothing but very, you know, these cars are nothing but not even having any collisions. Let me tell you why. So there are four cars, right? There are four cars. Now, this car is moving in the left direction. Okay, this is moving in the left direction. This is moving in the left direction. Now, this car is moving in the right direction. This car is moving in the right direction. These two cars moves in the direction, like, let me tell you how does they move. They move like this. They move like this. They don't collide. They both go in the same speed. Don't say that this is moving in the right direction, this is moving in the direction. So this car will move with the higher speed and this will collide with this car. No, it's about directions. It's not about the speed, right? So, okay, they both are moving in the right direction. And let's go with this left. Now, these two moves like this, and as I already said, they both don't collide. Now, what does it tell you? All the lefts, all the rights at the end, rights at the end, lefts at the end, just ignore them. We just need to ignore them. They don't have any thing about this car collision. Let's take something like this: R, L, S, or anything. Let me tell you this clearly. If there is an R, it will collide with L. But let us be clear, this R will add the answer by 1. I will tell you again, this R will add to the answer by 1. But this L also adds the answer by 1. Let me tell you why. Every time I have an R, every time I have the L, I'm adding 1. So I'm just adding 2. That's what they said, and that's what I'm doing. Now, you might ask me, there is a stationary car and there is a car like left here, and there is a car like, okay, just let's take this, right? The same example, I think. Okay, the stationary car and a left car. So what I'll do I have, I said the stationary car I'm not gonna use that, but when I come to this left car, I'll add that 1 to the answer, and answer will be added by 1. Okay, now this car will collide with S. That's it. Now there is another left that will collide with this one. There is another right and then left. This will add to the one. So there is an L. This will add to the one. There is an L. This will add to one. You know, every time, every time I get R or L, add 1. No need to do anything about the stationary, the stationary car. Okay, I'm adding 1. So before that, what I did, remove all beginning else in the beginning, else in the beginning, and also remove all r's at the end. What do you think about it? You are removing all else, you are removing all r's at the end, and if there is an r or l, I'll just increment the an answer, right? And at the last we'll return answer at the end. So what is the time complexity actually? We go of n, and the space complexity, we are not using any array or any data structure, so it will be big of 1. And I have given the code link in the description. Go and check it. Thanks for watching this video. Please do like, share, and subscribe to my channel. I did the same thing. I just skipped all the L's in the beginning. I just skipped all the R's at the end. And I started from k is equal to I, k is less than or equal to j. If S of k is equal to L or R, I'll just increment the answer or the collisions and return the collisions at the end. Thanks for watching this video.